Hello, my name is Muhammad Aiman bin JAMIAN. Today I want to talk about the introduction for our projects. As you know, beach play a special function in the transportation system, especially to connect to other side. There are many factors to take, such as geometry, span clearance, traffic flow, and available material. To build the bridge, the engineer should to apply structural analysis method to determine such deformation, internal force, support response, acceleration, and stability. The objective for our project is to design and build the lightest bridge with higher structural efficiency. The second one, to test the strength and weakness of bridge. We use some manual calculation and software such as StatPro and LeanPro. The third one is to enhance the student creativity and critical thinking in designing building.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN NAJMI bin SALMAN, BF21403. So I would like to continue the presentation with the layout and design. So firstly, we have designed our bridge using the StatPro application in the laptop, and the details of our bridge is such as type of truss, we use Warren truss, type of support reaction, we have pin and roller support, and lastly, modulus of elasticity of stainless steel, we use 210 gigapascal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin RIZZUDDIN, number matrix DF210045. So I will continue on the video presentation on the manual calculation part. For our group, we use the alternate method to calculate the internal force for each member. So first of all, we need to find its statically determinate or whether it is statically indeterminate. Firstly, we have to calculate the number of joint, which is 8, the number of member, which is the total member that been used, which is 13, and the number of reaction is 3, since we use the reactions such as roller and pin reaction. So by using the data gain, we can check the stability and determinacy by following the formula M plus R equal to 2J. So 13 plus 3 and 2 times 8 is equal to 16. So we can conclude that the structure is statically determinate truss. We continue on the manual calculation by finding the support reaction. So first of all, we look at point A and we make a summation of moment at A to find the value of VE. So after calculating, we find that VE is 75 kN upward. After that, we continue on finding the vertical, which is by using the summation of Fy is equal to 0. In that way, we will find the value of VA. VA is also 75 kN upward. And finally, find the horizontal part, which is summation of Fx is equal to 0. Since there is no other force that go horizontally, so we can say that HA is equal to 0. Next, after finding the support reaction, we can continue on the calculation by finding the internal force for each member. The internal force that we had gained had been shown at the slide shown. Then we continue by finding the force of member due to 1 unit load. As we can see, we choose point G to put the load vertically downward at 1 kN. And then we continue by finding its support reactions. So as we can see, firstly we start by finding the summation of moment at A, and then we find the value of VE. Then we followed by the summation of Fy equal to 0, and then we find the value for VA. After finding the support reaction, due to 1 unit load, we can find the internal force for each member by using the alternate method. The value that had been gained had been shown as the picture show. After finding the internal force F and force of member due to 1 unit load, we made a table that have the value for length, area, the modulus of elasticity to find the summation of FUL over AE. So as shown as the table, the total for FUL over A is 15001.85. Then we divided it by 200 times 10 to the power of 6. The value shown is the modulus of elasticity. So after dividing it, we find the deflection is 0.00075 meter downward.
We continue with the software calculation. For the software calculation, we have used application LinPro. And firstly, we design the truss or bridge in the LinPro, and then we put the support, which is pin support and roller support, and we place the external force that acting on the truss. And after all of that, we input the data and we run the analysis. After we run the analysis, it will show us the deflection of the beam, internal strength, and so on. So for this slide, I will show you our group deflection of the truss. Right, moving to the next slide. This is our internal force that calculated using LinPro. So this is the data that we had.
Our bridge is designed based on Warren Bridge with the dimension 4 meter high, 4 meter length from the starting point to the end point, and 4 meter width. We get a critical point which is very important, that the stronger the bridge, the lower value of deflection. The bridge height, material, type, manner in each member affect the strength of the bridge. There are differences between manual calculation and LinPro calculation. LinPro calculate more load cases, whereas an engineer need to work smarter to identify the key section and load cases. LinPro for calculate the deflection, while manual calculation is to calculate the internal force and actual force using alternative method, which is the method is very easy to use, other than another method which is we already know, joint method. But alternative method is the easiest way and the fastest way to get the answer.
In conclusion, the primary responsibility of an engineer is to plan the system for buildings and base while being ready to absorb any dangers to the structure. Additionally, it takes assurance and carefully consideration to ensure that the design is adequate, safe, and has its own unique aesthetic value in order to make it look distinctive with high security. That's all from us. Thank you.